Hello ladies, it's Mr. O'Sullivan. Today we're going to be looking at how to graph the equation of a line. So if you look on today's handout, there are some graphs, there are some equations, and there's some table of values. We're not going to use the table of values necessarily today. They're just there, for instance, if you wanted to basically copy the table from Desmos, you can create your table of values on Desmos and then use that to plot your line. But what we're going to do is we're going to focus on graphing them by hand. So here's your procedure. Today's learning target, is, I can graph a linear function by identifying the slope, y-intercept, and by using a calculator, you'll be using Desmos. Here are steps. Put the following into slope-intercept form. Make sure you identify your slope and y-intercept, and you're going to graph. So when we talk about slope-intercept form, what we want to do is we want to make sure each of the equations we look at today are in the form y equals mx plus b, where m is our slope, or our rate of change, and b is our y-intercept, or our starting point. And we always want to identify our slope, our y-intercept, and vice versa. So the first equation we're dealing with is 3y minus 3x equals 15. Thing is, that's not in slope-intercept form, so we're going to have to get it into slope-intercept form. So what I'm going to do is I'm going to rewrite this equation to the left-hand side of my page. My 3y minus 3x equals 15. And what we're going to do now is we're going to solve for y. So what I'm going to do is we want to get it into y equals mx plus b form. So I'm going to circle or square my 3y. And I want to basically get rid of everything else. So the only way to get rid of my subtract 3x is to add 3x to both sides. So I'm going to add 3x. My 3x's cancel, so I get 3y equals 3x plus 15. And we always put our x first because it just helps us make it look nicer. Now I have to ask myself, how do I get rid of the number attached to my y? And I'm going to divide everything by a 3. So my 3's cancel, so I get y equals 3 divided by 3 is 1. So I have 1x plus 5. And that's the equation of the line you're graphing. So here's what I like to do. I like to go under my equation and write down what my slope is. So my slope is 1, or 1 over 1, where 1 is my rise, and 1 is my run. So I'm going to be rising 1 and running 1. And my y-intercept is 5. So what we're going to do is we're going to plot the point 0, 5. You always plot your y-intercept first. So I'm going to plot my y-intercept right here. Ooh, not there. And then I'm going to be rising 1 and running 1. And that's a positive slope. So my line's going to look something like this. So when I rise 1 and run 1, it's going to look something like this. I'm going to plot these points in black. So I rise 1, run 1. I have a point here. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1, and so forth. Here's the issue. I don't want to plot points just in that direction, so I'm going to plot points in my other direction as well. So instead of rising 1 up, I'm going to rise 1 down and 1 to the left. So I have a point right here. So I can also do the exact same thing. Go down 1 over 1. Go down 1 over 1. Go down 1 over 1. And that's all I really need to plot. You don't need to plot many points. All you really need to do is plot like 2 or 3. The more you plot, the better it is because the more accurate your graph can be, and the nicer it looks. And then the last thing we do whenever we have our points plotted is that we draw a line going through those points. So I drew my line going through those points. I'm going to now draw arrows on it. And one thing we should always do is we should write the equation of this line. So 3y minus 3x equals 15. And that's how you graph a line. Now let's go to our next example. So in our next example, it's not in slope-intercept form because I don't know what my slope or my y-intercept is. I do know what my slope is by looking at it, but we want to solve for y. So what we're going to do is we're going to rewrite this equation. So y plus 2 equals 1/2 times x minus 6. And we want to get y by itself. But here's the issue. I have parentheses, so I'm going to distribute my 1/2 to each term on the inside. So I have y plus 2 equals 1/2 times x is 1/2 x. 1/2 times a -6 is a -3. I now have to ask myself, how do I get rid of my plus 2? Well, I subtract 2 from both sides. Subtract 2, subtract 2. So I get y equals 1/2 x. -3 minus 2 is -5. So that's the equation I'm going to be graphing. When looking at this, I know what my slope is. My slope is 1/2. It's the number attached to my x value. And my y-intercept is not positive 5, it's -5. So I have a positive slope and a negative y-intercept, so my graph is going to look something like this again. It's going to be going uphill. So the first thing we're going to do is we're going to plot our y-intercept at -5, and we're going to rise 1 and run 2. Rise 1 and run 2. So you're simply going to start at your y-intercept and go up 1 and then go to the right 2. So I go up 1 and then to the right 2, so right here. And I'm going to do the exact same procedure. I'm going to go up 1 over 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. So I have a nice picture of my graph in this quadrant, but I want to make sure I include a few more. So now instead of going up 1, I'm going to go down 1 and to the left 2. Down 1 to the left 2. Down 1 to the left 2. Down 1 to the left 2. And if you want, you can go one more, down 1 to the left 2. And we have a bunch of points plotted. But we need to make sure we connect those with a line. And then we put nice arrows on our line. So we're going to put our arrows on it. And then, last but not least, we name our line. So we are going to write y plus 2 equals 1/2 times x minus 6. And you just graphed a line. So in this example, we have it look a little different. It says f of x equals -2x plus 5. Remember, f of x is just a fancy way of saying y equals. So what I'm really doing is I'm graphing y equals -2x plus 5. So it's already in slope-intercept form, so I know what my slope is. My slope is the number attached to my x. My y-intercept is the number hanging out by itself. The number attached to my x is a -2. Whenever you have a whole number, I like to put it as a fraction, so -2 over 1. So -2 is my rise. 1 is my run. And that's why I like to put the 1 there. That way I know that I have to run 1. My y-intercept is a 5. And it's a positive 5. So we're going to go right ahead into graphing it. So we're going to plot our y-intercept at 0, 5. And when I have a negative slope, my graph is going downhill. So it's going to look something like this. So I'm going to go down 2 and to the right 1. Don't go to the left 1 because then you're saying you have a positive slope. So I'm going to go down 2 to the right 1. Down 2 to the right 1. Down 2, right 1, down 2, right 1, down 2, right 1. I can go a little further, but I'm not gonna. I'm going to plot some more points, but I'm going to plot them above. So now, instead of going down 2, I'm going to go up 2 and to the left 1. Up 2, left 1. And now I'm going to connect those points with a nice line. And last but not least, we put our arrowhead on it, and we name our line. So f of x equals -2x plus 5. And that's the equation of the line you just drew. Ooh, last but not least, we have a standard form. So standard form is going to be a little more tricky. I have x minus 3y equals 6. I don't know what my slope is. But here's the issue. I have a 1x. So make sure you remember that it's a 1x. You want to get it into y equals mx plus b form, so you want to solve for y. So what I'm going to do is I'm going to square my -3y and say don't touch it. So I have to ask myself, how do I get rid of a positive 1x? Well, I subtract 1x from both sides of my equation. My 1x's cancel, so I get -3y equals -1x plus 6. Remember, always put those x's first. And then last but not least, you need to get rid of this negative 3. So you have to ask yourself, how do I get rid of a multiplied by negative 3? I divide everything by negative 3. So my equation becomes y equals negative 1 divided by negative 3 is just 1/3. Always leave these as fractions. I don't want to see any decimals. X, and then 6 divided by negative 3 is a negative 2. So my equation I'm graphing is 1/3 x minus 2. So my slope is 1/3, which means my rise is 1, and my run is 3. My y-intercept is negative 2, because that's the number hanging out by itself. So I'm going to plot my y-intercept of negative 2. And I'm going to rise 1 and run 3. So go up 1 and to the right 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So I have some points plotted to the right. I want to plot some points to the left. So instead of now going up, I'm going to go down. So go down 1, left 3. Down 1, left 3. Ooh, not there. Down 1, left 3. 1, 2, 3. 1, 2, 3. And now I'm going to draw a line going through those points. And then last but not least, we put nice little arrows on our line. And we write the equation. So 1x minus 3y equals 6. And that's it. So if you have any questions, please email myself, Miss Townsend, or Miss Jimenez. Make sure you complete your Delta Math assignment, and if you have any questions, again, email us. Have a great day, ladies.